with the 5 vowels of English alphabet. You can also print out these individual vowels using the same square brace syntax. So if I copy vowels 2 from here and write system.out.println and put vowels and 2 inside square braces and print it out, you will see I printed out on the console. Yeah, as you can see, there is I. Now, you can also print out an entire array, but that's not as simple as printing out a single character or number or string. As you may have already guessed, the print, printf, or println function prints out stuff on the console as strings. So before you can print out the array, you will have to convert it to string. To do so, import the arrays class like this. Import java.util.arrays, and then inside the println method call, you will write arrays dot toString and then the name of the array, which in this case is vowels. See, we have printed out the entire array. Now you can also print out an array using loops, which you will learn in later lessons. For now, just be informed that there is also other ways of printing out an entire array to the console. So I have already mentioned that this array has a length of 5. And since its index count starts from 0, it will obviously end at 4. Now, if you try to put something in an index that doesn't exist, like 5, and maybe put x here, run the program, you will see that it fails with an exception saying index 5 out of bounds for length 5, which means for an array of length 5, you cannot have an index 5. Let's get rid of that line, and our code should be back to normal. Now, instead of declaring and defining your arrays separately, you can actually declare and define your array in one line. To do so, after you have written car, vowels, the pair of square braces, and equal, get rid of the new keyword and put a set of curly braces here. Then you can actually put the values and end the line with a semicolon. Get rid of these lines here and run the code. There you go. Now you can also replace any of these values from the array at any moment. For example, if you want to replace the I with any other character out there, you can do so in this way. Vowels, curly braces, and the index of I is 0, 1, 2. So put 2 here, equals, and put x. Put a semicolon at the end, run the program, and as you can see, the I has indeed been replaced with x. Another thing that I forgot to mention is the fact that when you are declaring and defining your array in a single line, the array will actually infer its length from the number of values you are defining it with. So since there are 5 values in the definition, the array's length will always be 5. Now, like strings, arrays in Java are reference types, and like strings, arrays also have a bunch of useful methods in them. For example, if you ever want to know about the length of an array, you can do so by saying, let's get rid of this line first. And you can write the name of the array, vowels, and dot length. I hope you remember that in case of a string, the length was actually a method, but in case of an array, it's a property. So if we run the program, and you can see the length of the array. One of the most common tasks regarding arrays that you may have to do again and again within your programs is sorting an unsorted array. Right now, we have ordered our vowels array according to the order of the letter as they come in the English alphabet. So A, E, I, O, U. But if we change the order and kind of randomize it, so I will put E first, then U, A, and I. So A, E, I, O, U. Then it's totally out of order. Now there is a method called sort within the arrays class that you can use to sort your arrays in order. To do so, you will have to write arrays.sort and then put the name of the array, vowels. Then let's bring back our arrays.toString method and we'll say vowels. Let's run the program and see if it works or not. So it turns out that the arrays.sort method takes an array as its parameter and it sorts the array in place. So it actually changes the original source array. Now by default, the arrays.sort method performs the sorting on the entire array. So it will begin from the first letter and go through the entire array until it reaches the last letter and sort them in order. But if you want to perform the sorting within a certain range of the array, let's say, for example, if I want to keep the E and I as they are right now, and I just want to sort the U, A, and O, I can do so. So after I have put the array name, now to define the starting and ending index of the sort method, you can let's just define two integers here. So int starting index equals, I'd like to start the sorting from U, so 0, 1. Then in ending index, I want to perform the sorting until O. But here is the thing. If I put 0, 1, 0, 1, 2, 3, 3 as the ending index, the O will be left out from the sorting because the ending index is usually not inclusive in this case. So I will have to write 4, which means the sorting will take place from U to O and it will actually not affect I. Let's test it out. After I have written the name of the array, I will put a comma here and I will put the starting index, then the ending index, save my code and run it. So as you can see, the sort method has actually sorted A, O, U in order and did not touch E and I at all. So this is one of the useful things that you should know about sorting arrays in Java. Apart from sorting an array, you may also want to search for a certain value within an array. Okay, so for example, we have E, U, A, O, I here, and if you want to look for O in the entire array, you can do so by using the arrays.binary search method. Now, one thing that you will have to remember is that this arrays.binary search method only works on sorted arrays. So if you have an array that is not in order, make sure you have sorted it before performing the search. Now to search for maybe O within this array, I will say arrays dot binary search, and then I'll put the name of the array that I want to perform the search on, so vowels, and then the key or the item I'm looking for. So I will write key, and I create a new character here, car key equals to, and I'm looking for what? I'm looking for O, semicolon. Okay, now this binary search method right here returns an integer, which is the index of this key if found. So I will write int found item index equals to arrays.binary search vowels key. Excellent. Now first I would like to print out the entire array, and then I would like to print out the found item index key. So found item index key. Let's save the code and test it out. Sorry, I mistyped the name of the variable here. Mistakes like this can happen. Yeah. So in the array A, E, I, O, U, O is at index number 3. So we can verify that 0, 1, 2, and 3. O is at index number 3. Like the sort method that you learned about just a few moments ago, the arrays.binary search method can also take an starting and an ending index. To use them, first we will need to define the index integers like int starting index. I think I should have just kept them. And I will start the search from 1. So I put 1. Then I will also create an ending index equals to 4, because I want to perform the search within the middle 3 values, and like the sort method, the ending index is not inclusive in this case as well. So once I have defined the 2 integer numbers, I will say binary search vowels, and then the starting index, comma, the ending index, and finally the key I am looking for. Now let's see if it works or not. Run. Okay, so it says 3, which is correct in this case as well. I have found O at 0, 1, 2, 3. Now, so far in this lesson, I have shown you a bunch of searches, and all of them has worked out fine. But what will happen if one of your searches fail to find the value you're looking for? For example, we do not have an X in the entire array. So if I get rid of the starting and ending index and look for an X within our array, you will see that the output is -6. Now, instead of looking for an X, if I look for a B within our array, you will see that the output changes from -6 to -2. So you may have already guessed that depending on the item you are looking for, and if it doesn't exist within your array, then the output can differ. But one thing that's constant is if the search fails, you will always get a negative output. And if the search succeeds, you will get a positive output, and that positive number will be one of the indexes from your array where the item you're looking for exists. Now, there is a way to actually calculate this value. There's logic behind why the output is sometimes 2 and sometimes 6. But I will not get into that much details in this course. If you are interested about learning this, I will leave the link to this article on FreeCodeCamp under this video's description, so you can follow that link and read more about it. Now, being able to sort an unsorted array and look for any certain item within an array is useful. Now, another small but useful thing that you can do with arrays is that you can fill them with a certain value. For example, we have 5 vowels listed out of order within our vowels array, but maybe for some reason you want to fill the entire array with X or maybe empty characters. Now you can do that by using the arrays.fill method. Before that, let's get rid of some of these codes and write arrays.fill. Then put the name of the array that you want to fill, which is vowels, and the character or the value that you want to fill the entire array with. Let's run the code and see if it works or not. Yeah, as you can see, the entire array has been filled with X's. Now you can also have starting and ending indices with this fill method. Starting index equals, let's start from 1, and ending index equals to 4. This is the same drill with the other methods as well. The ending index is never inclusive. So if you want to perform the fill from 1 to 3 upon these 3 values, make sure to include the last one as well, or the item that's just after the one you want to end the fill action at. Okay. Now arrays.fill, vowels. Then we will put the starting index, the ending index, finally the value that you want to fill the array with. Okay, so arrays.toString vowels. Let's see if it works or not. Yeah, it does. The E and I is untouched, and the U and O and A has been replaced with X's. I have already said that arrays in Java are reference types, and one of the complexities that we get with any reference types out there is making copies of them. For example, if we have an array of integers this time, just for changing our test a bit, I will write int numbers, same thing, equals, then inside of a pair of curly braces, I will put 1, 2, 3, 4, and 5. Then I will create another array saying int copy of numbers, which is an array, equals to the numbers array. Okay, so ideally the copy of numbers array should be a copy of the original numbers array, right? Let's see if that's true or not. Print ln arrays dot toString numbers. Let's make a copy of this line and put copy of numbers. Sorry. Let's run the code and see what happens. Turns out I have made another typo here. I have missed a T. Let's put it back and run the program. So it seems like that the copy of numbers array is indeed a copy of the original numbers array. But I'm not convinced. Let's do another thing, okay? Let's make some changes to the original array. So we can say arrays dot fill numbers, and I'll fill the original array with zeros and then run the code. Let's see what happens. But this is unexpected, isn't it? I have actually made some changes to the source arrays, and the changes have somehow applied to the copy as well. Well, the reason for this is the fact that arrays in Java are reference types, and when you use an assignment operator to make a copy of an array or any other reference type for that matter, it doesn't actually make an entirely new copy of the source material. What it does is it creates a new variable and points that variable to the original source array. So although the second array has a different name, it's still pointing to the same values. So you can treat this copy of numbers array as kind of an alias for the original numbers array. So how do you make a copy of an array correctly then? Now, to copy an array properly, you will have to use the arrays dot copy of method. The method takes the name of the original array as its first argument, and as the second argument, it asks for the length of the new array. So the length of the original array, as we can see, is 1, 2, 3, 4, 5. So you can count that by hand, or you can be a little bit clever and put numbers dot length as the length for the new array. Let's run the code and see whether the copy gets affected by the fill call or not this time. So as you can see that the original source material and the copy of it are now two separate entities, which we want. Now, instead of putting the same length as the original array, you can also make the array larger or smaller. Let's say if you make it larger with 10 indexes, you can do so. So as you can see, the first 5 elements of the copied array are from the original array, and the rest of the indexes has been filled with 0, which is the default value for integers. You can also make it smaller, so 2. And the copy array can hold only 2 values, while the original array could hold 5. Now, like the sort and the search method, you can also define the starting and ending indexes for the arrays.copyOf method. But for that, instead of using the copyOf method, you will have to use copyOfRange. Now, inside this method, you will have to first give it the name of the source array, then a starting index and an ending index. And just like before, we will have to define these integers here. Int a starting index equals to 0, 1. Let's start the copy from 1. And int ending index equals to 4. Let's run the code and see what happens. So as you can see, the method has successfully copied 2, 3, and 4 from the source array. Now, one thing that you may have already noticed that in case of the copy of range method, you do not need to use a length for the newly copied array. So how can you increase the length of the new array if you want to? Well, right now we are performing the copy from index number 1 to index number 4, right? So if we put a larger value than the original length of the array, like 10, let's see what happens. So as you can see, the copy works out fine. The method copies 2, 3, and 4 from the original array, also 5, and then fills up the rest of the space with zeros. So although you cannot explicitly define a new length for your copied array, you can change the length of the new array by changing the ending index of the copy of range method. Just like copying a reference type is more complex than copying a primitive type, comparing reference type is also a bit complicated. I hope you remember from our lessons on string, we couldn't compare two strings simply using the equals equals signs. We had to actually use the equals method. So it's kind of similar in case of arrays. Say, for example, we have the original numbers array. Then we have a copy of the numbers array. Let's just use copy of instead. Numbers dot length, excellent. And get rid of the fill method. And try to compare our arrays using the equality operator. So we'll say numbers equals copy of numbers. Let's run the code and see what happens. As you can see, it says false, but we know for sure that the copy of numbers array is an identical copy of the original source material. Now to compare to identical arrays like this, or maybe to different arrays, what you will have to do is you will have to write arrays dot equals, then inside this method you will have to pass the two arrays, copy of numbers. Let's run the code and see what happens. Yeah, this time it comes out as true. Since there is no such thing as casing in case of an array, there is no equals ignore case method for arrays like we had for strings. In programming, you may want to repeat a certain set of instructions again and again for your projects. You can do that by using loops. Now, there are 4 kinds of loops in Java, and we will start our discussion with a for loop. First, I will write out the code for a very simple for loop in Java that can print out the number from 1 to 10. For that, I will write for, this is the starting of our for loop. Then inside, I will take an integer, int number equals to 1. Now after the semicolon, I will write number is less than or equal 10, and then number plus plus. Then I will put a set of curly braces here, and inside this block of code, I will write system.out.println number. We do not need the arrays class import right now, so we will get rid of that. And let's run the code and see what happens. Then I will explain each line of this for loop to you. As you can see, the program successfully prints out all the numbers from 1 to 10. So what's going on here? Well, every single for loop usually has 4 parts. The first part is the initialization, where we are initializing a certain variable, in this case an integer with the initial value of 1. Then there is a condition that we are checking against. So we are checking whether the number is less than or equal to 10 or not. And if the number is less than or equal to 10, we will print out the number. So this is the loop body, system.out.println. Anything that you write inside this set of curly braces will be the loop body. Then once we are done with the loop body, we will go to the third part here inside the set of parentheses, and this is called the update, and we will update the value of the number variable. So I will repeat. Every single for loop will have 4 parts. There is the initialization, where we initialize a variable with a value. Then there is a condition that we will check in every iteration. There is the loop body, and then there is the update. So when this loop runs for the first time, the value of number will be 1. And this condition will be true since 1 is indeed less than 10. So the loop will print out the value of number, which in this case is 1. Then the loop will increase the value of number by 1 and go back to the condition part and check whether the updated value is less than or equal to 10 or not. Well, 2 is less than 10, so it will again go inside the loop body and print out 2 on the console. So like this, the loop will keep printing out all this number until it reaches 10. When the loop has printed out 10 on the screen, it will go back to the update part and increase the value of number from 10 to 11. And it will go back to the condition once again and check whether 11 is less than or equal to 10 or not. In this case, the condition will come out as false and the loop will stop iterating. The program ends here and we get all the numbers between 1 to 10 printed out on our console. I hope that makes sense. You can also use a for loop to loop over an array. For example, if we create an array here, int numbers equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then we can use this for loop to loop over this array and print out each of this number. To do so, we will need an integer and we can call that the index. So we want to run this loop as long as the index is less than the length of this array. So numbers dot length Finally, we will increase the value of index by 1 on every iteration. Finally, inside the println call, we will say numbers and then we will put the index here. Let's see if it works or not. So as you can see, the program actually prints out all the numbers from 2 to 10 and doesn't print out 1, because since the index count starts from 1, which is its initial value, it starts accessing the array elements from index 1. So if you change the value of index from 1 to 0, then you should get all the numbers from 1 to 10. So what's happening here is you are initializing an integer with a value of 0, and then inside the condition part, you are checking whether the value of the index is less than the length of the numbers array or not. If it's less than the length of the numbers array, then you go inside the loop body and print out whatever number is in the current index. So it starts from index 0, which means 1, then index 1, which is 2, then 3, 4, 5, 6, and so on. You can also do some interesting things within this loop. Instead of printing out all the values, you can add them all together and print out the sum to the screen. To do that, what you will need is you will need another integer here equals to 0. Initially, the sum will be 0. And then inside the loop, what we are going to do is we will say sum plus equals numbers and then the index. Okay, finally we'll move out this system.out.println outside of this loop and print the sum on the screen. Let's see what happens when we run the code. I forgot the semicolon here. Yeah. So the sum of all the numbers from 1 to 10 is 55. Now let me show you two more interesting programs that you can write using a for loop. The first one is that you can print out multiplication tables of any number using nested for loops. For that, what we need is a number. So we will begin by taking a new integer int number 5. Then inside the for loop, let's get rid of all this code and rewrite the for loop from scratch. So we will say for, then another integer, the multiplier. We will begin from 1. Then if the multiplier is less than 10, we will keep going, and we'll also increase the value of multiplier by 1. Then inside the loop body, we can say system.out.printf, in this case, modulus d into modulus d is equals modulus d. Now we will say number, then the second part would be the multiplier, and finally number into multiplier. Now I hope you remember that the printf method doesn't have any new line character at the end. So if you run the program at its current state, let's see what happens. As you can see, it prints out the entire multiplication table in a single line, which we do not want. So what we can do is we can put a \n at the end of the line, which will print out each row in a new line. Run the program. Excellent. Now we can take it a bit further, to be honest. Let's get rid of the current code. And let's begin with a new for loop, okay? For int number equals 1, number is less than 10, and number plus plus. Then inside the for loop, we will have a nested for loop. I hope you remember that we have worked with nested if statements in the past. We can also nest for loops within each other. So we can do for int multiplier equals 1, multiplier is less than 10, and multiplier plus plus. Now inside the loop body, we will say system.out.printf modulus d into modulus d equals to modulus d. So the first thing would be the number. So since the nested for loop is inside the outer for loop. Any variable declared within the outer for loop will be accessible inside the nested for loop. But any variable that you declare inside the nested loop, such as this multiplier here, will not be visible to the outer loop. So we can say number. So we will replace the first modulus d with a number. Then we will say multiplier. And finally, number into multiplier. End the line, save our code, and let's run it. Okay, just like before, we have to add a new line character at the end to make it look a bit nicer. So as you can see, now we have successfully printed out the multiplication table for all the numbers from 1 to 9. But if you'd like to include 10 here, you can say less than or equal and then run the code. Yeah, it works fine. And I also just noticed that we are missing 10 here, and you can fix that by saying multiplier is less than or equal to 10. Run. So let me explain what happens here. First, inside the outer for loop, you are initializing a number with 1 and you are continuing to loop until the value of number exceeds 10, so less than or equal 10. And then inside the loop body, you have another loop. So first it comes and says, okay, number is equals 1, it's less than 10. Then it goes inside the inner for loop and it sees that there is a multiplier with the value of 1. Multiplier's value is less than 10, then it goes inside the body. Once the body has been executed, it prints out 1 into 1 equals 1. And then it goes back to the update part of the inner loop and it checks again, then it keeps looping within the inner loop. Once the value of multiplier has exceeded 10, the inner loop breaks and the program goes back to the outer loop. It increases the value of number by 1, which becomes 2 now, and it goes inside the inner loop again and prints out the multiplication table for 2. Then it goes on to print out 3, 4, 5, 6, 7, 8, 9, and 10. So if you're having difficulty deciphering this complicated code here, I would suggest that you write this code yourself and use a notebook to understand how these values changes in each iteration. Okay, so finally, I would like to show you an example of using an if-else statement within a for loop. For example, if I tell you to print out all the odd numbers from 1 to 50, you can do that by using a for loop and a single if-else statement. Let's begin. For int number equals 1, number is less than or equals to 50, number plus plus. So this loop will begin at 1 and end at 50. Then inside the loop body, what we want to do is we want to check if number modulus 2 is equals 1, then system.out.println number. So if you divide a number by 2 and the remainder is 1, it's pretty sure that the number is an odd number. We all know that. So what we are doing is inside the for loop, we are taking whatever the value of number is, we are dividing that by 2 and checking if the remainder is 1 or not. That's what the modulo operator is for. I hope you remember. And if the number is an odd number, we will print it out. And if it is an even number, we will skip that. Let's run the code and see what happens. So as you can see, we have successfully printed out all the odd numbers from 1 to 50. So 1, 3, 5, 7, 9, 11, 13, 15, and it goes on to 45, 47, and 49. There is another variant of the for loop that makes looping over collections such as arrays much easier. Now for that, first we will need an array numbers equals, I'll just put the regular numbers there. There you go. Now, to use this special type of for loop, you will have to write for, then inside you will say int number. This type has to match with the type of the array, and then you will put a colon here, and then you will put the name of the array. Then inside the array body, you can say system.out.println number. Let's see what happens. So as you can see, the loop successfully goes through the entire array and prints out each element to the console. Now what's happening here is you are saying for every single integer number in the numbers array, you want to print them out. So instead of using an integer as an index and accessing the elements individually, you are kind of taking a shortcut and extracting each value from the numbers array and putting them in the number variable on each iteration. Now you can do anything that you could have done in a regular for loop, such as if you want the sum of all these numbers, you can do so like this. Sum plus equals number, and then system.out.println sum. Make sure you're putting the println call outside of the loop, otherwise this will be printed every single time the loop iterates. Let's run the code and see what happens. There you go. Other than the for loop, there is also the while loop and do while loop in Java. These are two different kinds of loops that can more or less do the same thing as a for loop, but the for loops are a lot more common in the wild than the while loops. Now I will show you two examples of using a while and do while loop. First, let's begin with the while loop. We will simply print out the multiplication table like we did in the case of the for loop, but this time we will use a while loop. Now first, you will need a number, just like before. Then you will need the multiplier. Now to write a while loop, you will have to say while multiplier is less than or equals 10. Then inside the loop body, you will say system.out.printf modulus d into modulus d equals modulus d. Since all of the variables are integers in this case, then you will put number, then the multiplier, finally the number into multiplier. Excellent. Then once you have printed out the row in the multiplication table, you will have to increase the multiplier by 1. Multiplier plus plus. Let's run the code and see what happens. So yeah, looks like the program works just fine. We have to just put a new line character to make the output a bit more readable. There you go. Now, the main difference between a while loop and a for loop is the fact that the while loop only has one component, which is the condition. In case of a for loop, we had the initialization, we had the condition, we had the loop body, and we also had the update part. But in this case, there is just the condition, and of course, we have the loop body. So you will have to do the initializations outside of the loop, and you will have to perform the update or the incrementation of the multiplier or maybe counter or whatever you are working with inside the loop's body. So this is how a while loop looks like. Now, a do while loop works similarly but in a different order and also looks a bit different. So in case of a do while loop, you will have to write do, then you will have the loop body, which in our case is these two lines. We want to print out the multiplication table once again and also increase the multiplier. And after the loop body, you will say while multiplier is less than or equals 10. Let's comment out our old while loop. Make our console bigger and run the code. See, it gives you the same output. Now, the main difference between a regular while loop and a do while loop is the fact that in this case, first, the loop body will be executed and then the condition will be checked. Whereas in case of a while loop, the condition gets evaluated and then the loop body gets executed. So you will surely find usage of both kind of loops if you work long enough. But I can say from experience that for loops are a lot more common than whiles or do whiles. Let's just clean up our code before we leave from this lesson. Yeah. So far in this course, you have learned about only one way of putting a bunch of values together, and that is the arrays. But arrays have some limitation, and the biggest one of them is the fact that you cannot resize an array. The only way to make an array larger or smaller than it already is to copy it and change its length during the copy. But there is another type, an array list, which is like a dynamic array. You can create an array list, you can put item in it, or you can take away items from it, and it will also adjust its length depending on how many elements it's holding. Now, to use an array list in your code, you will have to first import the array list class. To do so, you will have to write import java.util.arraylist. Then, to create an array list, you will have to write array list. Then you will have to put a less than sign, and inside you will have to write the type of the data you want to store in this array list. Now, I know so far you have been only seeing int, and this is the first time you are seeing something called an integer used as a type. I will explain what this is, but let's just keep on typing and finish creating our new array list, okay? So array list integer, then name of the array list, which in this case will be number, equals new array list integer. That's it. We now have an empty array list of integers. I forgot the S there. Now, what's this integer class here? I have taught you that data types such as int or double or float, boolean, these are all primitive types. But in Java, you can also make them as reference types using the wrapper classes. So this integer class here, integer, is actually a wrapper class for the primitive type int. In other words, integer is the reference type form of the regular int type. So just like integer, you also have double, float, boolean, and so on. And when you are creating an array list, you cannot use the primitive int type. You have to use the integer wrapper class. I hope that makes sense. Since we have an empty array list in our hand, let's put some item in it. Now, to insert a new item in an array list, you cannot just use the old curly braces syntax. Rather, you will have to use the add method. In this way, you will have to write numbers, then dot add, then the value that you are trying to add, which in this case will be 1, and a semicolon. You can make a bunch of copies of this line and just add other numbers as well. There you go. Now to print out an array list to the console, you will have to write system.out.println numbers, which is the name of our array list in this case, then dot toString. Now the toString is a method that is present in every single reference type in Java, and later on when you will learn about object-oriented programming, you will also learn about creating your own toString methods within your custom classes. For now, just remember that to print out an array list, you will have to write out the name of the array list first and then the method toString. Let's run the code and see if it runs fine or not. So as you can see, the array list looks like an array in the console. Now you can also print out a single value from the array list if you want to, but for that you will have to use the get method. So you'll say dot, then get, then the get method actually takes an integer which will be the index of the value you are trying to print. Like arrays, array lists are also 0 based. So the first index of an array list will always be 0. So the index of 1 in this case is 0, 2, 1, 2, 3, and 4. So if you want to print out 3 on the console, you will have to say numbers.get and then 2 here. Let's run the code. Beautiful. We have 3 printed out on the console. I have already said that array lists are dynamic. So you can add as many elements as you want using the add method, and you can also remove elements from an array list. So if you say numbers.remove, and it will take a number which will be the index of the element you are trying to delete. So if you want to remove 3 from our array list, we will say numbers.remove and pass 2. Then let's print out the entire array list and see if 3 exists or not. toString. Okay, let's run the code. Yeah, 3 has been successfully removed. But you can also remove items by value. So for example, if I want to get rid of 4, I can do so, but instead of passing an primitive 4, if you write 4 here, this will be a primitive integer type 4. It will work as an index, but if you pass a reference type 4 like this, integer dot value of, and then pass the primitive type, which in this case is 4, and if we run the code, you will see that we have successfully removed 4 from our array list. Now, an array list can store anything starting from integers, booleans, characters, strings, and your custom class objects, anything that you can think of. We will work with much more complex array lists in later lessons. For now, just let's get hang of the basics, okay? Now, you can also remove all the items from an array list by saying the name of the array list dot clear. This will clear out the entire array list and make it empty. There you go. So I have already showed you how you can add new items to an array list, how you can get them, remove them, clear an entire array list. Now let me show you how you can update an element inside an array list. For that, there is the set method. So you will type out the name of the array list, then dot, and you will say set, and you will have to put an index here. So again, let's update the 3 here, and its index is 2. We'll put 2 here, comma. Then you will have to put the value that you want to replace 3 with. And since the array list is of reference types, you will have to use the integer dot value of method once again, and we will say 30. So we will replace 3 with 30. Let's run the code and see what happens. Excellent. It works out just fine. So like an array, you can also sort your array list. Right now, we have added the numbers in a sequential order here, but if we randomize them, like for example, if we put 5 at the top, then 1 after 3, then 2 at the end, okay, let's get rid of these indices because now these are getting misleading. Okay, let's run the code and see what happens. So as you can see, the numbers are all jumbled around. Now to sort this array list, you will have to write the name of the array list, then dot, and then sort in the method. Now you can see that there is a small squiggly line under the sort method name, and this is because the sort method will actually take a parameter which is known as a comparator. Okay, so as you can see, it says comparator in the parameter list. Let me explain what this is. First, let's import the comparator class. So you'll say import java dot util dot comparator, and then inside the sort method we will say comparator dot natural order, which is a method inside the comparator class. And what we are saying is that sort this array list in its natural order. Okay, let's run the code and see if it works or not. Yeah, it works just fine. We have successfully sorted our array list. Now you can also reverse the order of this array list by saying comparator dot reverse order, which is similar to natural order, but this time all the values will be sorted in a reverse manner. There you go. We have 5, 4, 3, 2, 1, lift off. Now, three very small but useful methods that the array lists have is the size method, the contains method, and the empty method. First, let's see what the size method does. So if you ever want to know how many elements are there inside an array list, you can just say the name of the array list and then size. Now this size method will return an integer after counting all the elements in the array list. You can also check whether an array list contains a certain value or not, and to do that you will have to write contains, and since these are all reference type numbers, we will have to use the integer dot value of method, and we will have to put, for example, 1. Let's check if the array list contains 1 or not. So here it says true, which means it contains 1, and if we put 10 here, the output should be false. And yes, it does. Now there is another method that checks whether an array list contains anything at all or not, and it's the isEmpty method. And since our array list here actually contains some elements, the output should be false. And yes, it is. But if we clear our array list, just before checking for emptiness, we will see, yeah, it says true. Now the final thing that I would like to show you is the for each loop. Now you have learned about the for loop already in a previous lesson, and you know that you can use it to loop over regular arrays. But when it comes to an array list, there is another kind of loop. Let me show you how it works. Now keep in mind, the for each loop looks and works a lot differently than the for loops, but I'll try my best to explain them as lucidly as I can. So you will have to first write the name of the array list that you want to loop over, such as numbers, and then for each. Then here it says action. What you will say is number. Then you will make an arrow like this, and then a set of curly braces. Now inside the set of curly braces, you will say something like system dot out dot println, and let's multiply each number with 2 just as an example. So you'll say number into 2 and end our line. Now let's also print out the entire array list at the end. So numbers dot to string. Yeah. Let's run the code for now, and then I will explain what's happening inside the for each loop. Run. So as you can see, we have successfully multiplied each value in this array list, and we have also printed out the original array list here. Now let me explain the for each loop for you. So when you are saying numbers dot for each number, you are saying that for each number in the numbers array list, you want to perform the actions within this set of curly braces or within this block of code. So imagine this arrow like we are ordering the compiler, like for each number, perform this action that I'm pointing towards. Now, technically, it's called a lambda expression. It's like a method that doesn't have any name. Now, of course, I'm oversimplifying stuff here, but for now, this is enough to understand. Now, as you can see that although you are multiplying each value of the numbers array list with 2 inside the for each loop body, the original array list remains unchanged. Now, let's just for practice update the original array list and replace each value with their multiplied counterparts. Okay. Now, to do that, what we can do is let's first print out the original array list. We will say before and plus. Yeah, we are going to use the plus sign once again in this case because it's a simple program. And then we will take this out and we will say after plus and then numbers.toString. Okay. Now inside the for each loop, what we want to do is we want to say numbers dot set, and inside the set of parentheses we will say numbers dot index of, which is another method that can return the index of a given value. So we'll pass number here, comma, number into 2. So you are essentially using the index of method to get the index of the current value of the number variable, and then we are updating its element with the multiplied value. Okay, let's get rid of the println call here and let's keep our fingers crossed and try to run the program. Yeah, seems like it has worked out. We have successfully overwritten all the values of the array list with their multiplied counterparts. Now, this is one of the many fun programs that you can write to practice your skills. I would suggest that you go around the internet, find interesting problems that feels challenging to you and solve them to flex those Java muscles, okay? Now that you have learned about array lists, let me show you another kind of collection that's pretty common and pretty useful in some scenarios. These are called hash maps. Now, hash maps are actually key value pairs, and if you want to compare with Python, then Python dictionaries are kind of similar to hash maps. Now, to work with hash maps, first you will have to import the hash map class. To do so, you will just write import java.util.hashmap. Let's get rid of all the array list code and start working on hashmap. Okay. Now, to create a new hash map in Java, you will have to write hash map, and then just like the array list, you will have to first put the type of the key. So in my case, I'm making a hash map where I'll be storing the scores for my different subjects, maybe at my school or somewhere. So the key will be string, and the value will be the scores of the subject. So maybe English 98, maths 85, and so on. So this will be integers. And then I will name the hash map something, maybe exam scores equals to new hash map. string integer. That's it. We have successfully created an empty hash map, and since I have already discussed these wrapper classes in a previous lesson, I will not repeat. Now, to put something in this new hash map, you can use the put method. So exam scores dot put, and first we will need to put the name of the subject, so it will be a string and maybe math, and then a comma, and then the scores. I'm not that good at math, so maybe 75. Then we will say exam scores dot put another subject, maybe sociology, and 85 exam scores dot put English 95, and so on. Now, to print out a hash map to the console, you can say system.out.println exam scores dot toString, just like you did with the array list. Okay, let's run the code and see if everything works or not. Run. Excellent. The hash map prints out. So my score for English is 95, sociology 85, and math 75. I hope you have already guessed that the item you are putting into the hash map is not sorted. So even though I have put math at first, it comes out in the end. So if I put some more subjects, Bengali 100, computer programming 100, and let's see what order they show up in the console. So yes, they're actually showing up in random order. But that's how hash maps are. You don't have to worry about them. Now, you can also print out a single value from a hash map. To do so, you will have to write the name of the hash map, then a dot and get. Then you will have to pass a key. In our case, the keys are all strings. So I will write, let's get the score for English. Run. And yeah, we are getting the score of English. Now, apart from the put method, there is also another method, put if absent, that first checks if a value already exists in the hash map or not. And if it doesn't, then it will put it. Otherwise, it will just skip it. Now, you can write exam scores dot put if absent, and let's try out with math, and let's put a new value here, maybe 70, and then I will print out the entire hash map here, string. Nice. So as you can see, the value of math is still 75, even though I have tried to put a new value for it. But since the put if absent method actually checks whether math already exists or not in the hash map, it didn't override the original value. Now, if you want to replace one of the values, however, you can use the replace method. And it will take a key. In this case, we are still working with math, and we are updating its value from 75 to 70. What a shame. So as you can see, the value of math has been changed to 70. Now, just like the put if absent method, there is another method called get or default. For example, if I try to get a key that doesn't exist, let's say, for example, religion. We know that it doesn't exist in our hash map. Let's see what the output is. As you can see, it says null. But if we say get or default and we give it a default value of 0 or maybe -1 and run the code, so the program will return -1 if the given key is not found. Now, like an array list, you can clear a hash map by saying exam scores dot clear, and this should clear out the entire hash map. There you go. And now if you want to check the number of elements that exist on the hash map, you can do so by saying the name of the hash map dot size. This will return an integer after counting all the elements present in the hash map right now, which is 0 because we have just cleared it out. But if we get rid of that line, it should be back to 5. Excellent. To remove an item from the hash map, you can use the remove method like this, exam scores dot remove, and then you should put a name of the one of these keys. So let's get rid of sociology and I'll put it here, semicolon, then exam scores dot to be string. Let's run the code. As you can see, sociology is not present here. Now, you may also want to check whether a certain item exists on the hash map or not, and you can do that in two ways. Either you can check for a key or you can check for a value. For example, if I want to check if the math key exists or not, I can do so by saying the name of the hash map exam scores dot contains key, and then the key I want to check against, which is math in this case. And it comes out as true. Now, if I want to check if I have scored 100 in any of the subjects or not, I can do so by saying exam scores dot contains value and then the value I'm looking for, which in this case is 100. Now, you can also put a reference type 100 here if you want to do that. The value of, and it shouldn't make any difference. Yeah, it just works. And I have also taught you that in case of array list, when you are trying to update one of the values, you need to pass the integer as a reference type. You can actually pass a primitive type as well. The set method will convert it to a reference type automatically, but it's up to you what you would like to do and what you want. Finally, you can check if a hash map is empty or not by using the name of the hash map, which is exam scores dot is empty, and since our hash map is not empty, this should return false. Yeah, it returns as false. Hash maps also have for each loop, just like ArrayList. And now I will show you an example of using them with hash maps. To do so, first you will need to write out the name of the hash map, which is exam scores in this case. Then you will set dot for each. Just like ArrayList, you will create a new lambda method here, but in this case, you will say the key, comma, the value, then the arrow, and the curly braces. Now the key here is the subject and the value is the score. So I'll just do it like this. And then system.out.println name of the subject plus dash plus the associated score. Let's put a semicolon at the end. Get rid of the isEmpty call and see if it works or not. Okay, I just noticed that there is a small squiggly line here. That's because I didn't enclose the two variables within a set of parentheses here. In case of an array list, we had only one variable, so we didn't need these parentheses. But since we have multiple variables here, subject and score, we will need a set of parentheses around them. Let's run the code and see if it works or not. Okay, seems like it works. Now, what we are going to do, we will loop over the entire hash map just like we did in case of the array list, and we will update the value of each subject score just for the purpose of practice. Now, to do that, we already have the name of the subject, which is the key, and we also have the value, which is the score. To update the values, we will say exam scores dot replace. You have already learned about this. Then we will say subject, which is the key, and then we will take away 10 from each subject, maybe for bad behavior or something. Then we will say system.out.println and exam scores dot toString. Okay, I hope everything works out fine and I cannot spot any mistakes. Let's hit the run button. Yeah, so I have indeed taken away 10 from each subject. So English was 95 and now it's 85. Bengali was 100 and now it's 90. Sociology is 75 from 85. Computer programming has become 90 from 100. And finally, math has become 65 from 75. Again, I would suggest that you go into the internet looking for problems that you can solve to just practice all the things you are learning in this course. This will really make you confident in Java. Now that you have learned most of the basics of Java, it's time that we start discussing about object-oriented programming. Now, the concept of object-oriented programming in itself is really huge. And to be very honest, you cannot learn how to make good object-oriented programs from a course or a book. What I can do is I can teach you the basic concepts around object-oriented programming. And once you have learned them, you will have to learn the rest from experience by making larger and larger software, following good practices, and so on. Now, at a higher level, object-oriented programming is about modeling your software around real-life objects. For example, maybe we can build a book borrowing system where a user can come register and log in, check for a book's availability, borrow it if it's available, and they can also return it on time. They can also check the list of the books they have borrowed so far. Now, in this aforementioned system, there can be two objects. one, the user, and two, the book. We can store information such as the user's name and birthday. And in case of a book, we can store the book's title and maybe the name of its authors and so on. So let's begin by creating a user class in our software. And as we keep working on this simple program, we will learn about the different concepts around object-oriented programming. So first, open up the Files menu by clicking on the file icon here and click on the Add File button. Name your new file user.java. In this file, we will need to create a new class like we have done with the hello world file. So write public class user. Now we are declaring this class as public because we want this class to be available within our entire program. Now inside the class, we will store the user's name, which can be string. So public string name. And we will also store the user's date of birth. So we will say public local date, which is a reference type for storing dates in Java, and we'll say birthday. Now to use the local date class within our user class, we will have to first import it. So import java.time.localDate. By the way, do not get intimidated about the amount of classes that Java has built into it, as you will keep working with Java for months or maybe for years. You will eventually learn about a lot of them. Now we have a new user class. Let's go back to our hello world class and create a new user object. Now creating a custom object like a user object is not very different from creating a string. So you will have to write user, which will be the type of our object. Then you will have to name the object. Maybe let's name it younger user because we will have an older user as well later on. Equals new user and a set of parentheses. Now we have a user, but this user at its current state doesn't have any name or date of birth. Since these variables are declared in the class level of the user class, these will be initialized as null by default. So they will get default values. Now variables like these at a class level are called properties. And since these properties are tagged as public, we can actually access them from outside of the user class and give some value to them. So we will say younger user dot name equals Farhan Hassin Jr. Excellent. Then younger user dot birthday equals local date dot parse, and inside the parse method we will pass 1995 01 31, which means 31st January 1995. Now the local date.parse method can parse a date from a given string and convert it to local date type. Again, for using the local date class here, we will have to first import it. So import java.time.localDate. Then we would also like to print something out on the screen, and for that we'll say system.out.printf, and inside the printf method we will say that modulus s was born back in modulus s. Then after the comma we will replace the first format specifier here with the name. So we will say younger user dot name, and then after that we would like to replace the second format specifier with the birthday. But since the birthday is not a string, you will have to first convert it to a string by calling the toString method. And I've already said that the toString method usually exists in all the reference types, and any local date object is actually reference type. Let's try running our program and see if it works or not. So yeah, it works just fine. Farhan Hassin Jr. was born back in 1995, 0131. Now, I have already said once that using something called methods, we can actually implement some dynamic behaviors to our classes. For example, since we have the birthday of the user, we can use it to calculate their current age. So we will create a new public method, public, because we want this method to be accessible throughout our entire program. And then we will have to write the return type of our method, which in this case is integer because age is always an integer. Then we will put the name of the method, which is age, and put a pair of curly braces. Now from inside the method, we will calculate the age, int age equals, and for that, Java actually has a pretty nifty class. So we will import java.time.period. Now this period class has some method that you can use to calculate the difference between two local date times. So we will say period dot between, and inside this method call we will put a starting date, which is the birthday. So we will say this dot birthday. I will explain this later on. And then we'll put local date dot now. Now this period dot between method call will actually calculate the difference between the user's birthday and our current date. And then we would like to return age dot get years, because we want to return the age in years. Okay, we do not want anything else. Let's go back to our hello world class and change this string to something like was born back in, and he is now modulus s and modulus d years old. So you'll say the user was born back in the birthday and he is now X years old. So we'll put a comma after the toString call and say younger user dot age, and we'll put a set of parentheses because this is a method and you will need to put a set of parentheses to call any method in Java. Let's run the program and see if it works or not. Yeah, looks like everything has worked out just fine. It says Farhan Hassin Jr. was born back in 1995, 0131, and he is now 27 years old. Excellent. Now, what is this this keyword here? Now, to explain this, we will actually need two users. So let's create a new user, older user equals new user, and we'll say older user dot name equals Farhan Hassin Senior, and then we'll say older user dot birthday equals local date dot birth, and let's put 1975 0115. Okay, now we'll put this system out dot printf at line 10, and we will make a copy of it at the end of our program. was born back in okay, all right, let's replace younger user with older user. Let's run the code and see what happens. Okay, so Farhan Hassan Jr. was born 27 years old and this is 47 years old. Nice. Now you can see that we have two different users in our program, and both of these users are actually created from the same user class. So when we are trying to calculate the age of the user, how would the computer know which user we are referring to or which date of birth we are referring to? This is where this keyword comes in. You see, we have two instances of the user class here, and this keyword will refer to the current object being worked on. So when we are saying younger user dot age, then the value of this will be the younger user object. And when we are saying older user dot age, the value of this would be the older user object. Okay, so let's get rid of the extra user here. Change the younger user's name to just user. And let's start working on the book class. Let's go back to the files menu, create a new file with the name book.java. Now let's declare a new class, public class book. And for a book, we would like to store a public string title and public string author. Yeah, that's pretty much it for the book class. Now let's go back to the hello world again. And we will say book equals to new book, and then book dot title equals to Carmilla, book dot author equals to Sheridan Le Fan. Let's put a semicolon at the end, and now we have a new book. So how about we implement the functionality of borrowing books? I will put it in the user class. So let's close this menu as we don't need that. And we will create a new method here, public borrow. And this borrow method will actually accept a parameter because this method has to know which book the user is trying to borrow, right? So we will say book. So this method is actually accepting variable of book type. Then let's create array list of type book. Let's call it books equals new array list and book. Close it. And we'll also have to import the array list class. So import java.util.arraylist. Okay, then we can say this dot books dot add and book. So we are adding the book we have received within the borrow method to our list of books. Okay, let's go back to our hello world class and we will say user dot borrow and we will pass the book to it. I think we have made a small mistake, that is we haven't said what kind of data the borrow method is returning. Now as you can see, the method actually returning nothing, so we will have to say void, which means it doesn't return anything at all. There is no return statement whatsoever. It just makes some changes to the books array list. Okay, let's go back to hello world, and this looks all right so far. Let's update this printf method. Yeah, at age. Okay, let's write another one. System.out.printf, and we'll say modulus s has borrowed these books, and we will say modulus s. Okay, let's put a comma here, and we will say user.name has borrowed user.books dot toString. Okay, let's also put a new line character at the end of our printf statements, otherwise they may not look as good as we want them to be. Okay, let's run the program and see what happens. Then we will go through what's happening in this entire system once again. Okay, just as I expected. So as you can see, it says Farhan Hassin Jr. was born back in 1919 and so on. And then it says Farhan Hassin Jr. has borrowed these books, book at, and then a large number. But we are expecting maybe the name of the book or maybe the name of the author or something like that, right? But that didn't happen. Let me tell you why. You can see that we have been using the method toString a lot, right? We're using the method toString a lot, and I have already said that this toString method comes with every single reference types. Now our book here is a custom class, and whatever book object we are working with are all reference types. Now, since we have created the book class ourselves, it doesn't have a built-in toString method. That's why we are getting some random values here. Now, to solve this problem, we will have to implement a toString method. We can do that by saying public string toString, and then we will return a string representation of this book, like return string.format here, and we'll say modulus s by modulus s, then a full stop. And after the comma, we will say this dot title and this dot author. So whenever we are trying to access one of the properties within a class from a method within the same class, we can use the this keyword. Okay, let's try to run the program once again and see if it solves our issue or not. Let's make our console bigger. Yeah, now it looks much better. So Farhan Hassin Jr. has borrowed these books, Carmilla by Sheridan Le Fanu. I think that full stop there looks pretty bad because it's going to show up like a list of books. Let's get rid of that. And also, I think this is a good time to switch back to the stacked layout once again, since our codes are getting bigger horizontally, and this gives us a better look at our lines. Okay, so what have we done so far? We have created two custom classes representing our users and the books. We have created a new user object. We have given him the ability to borrow books from us. We have also calculated their age using method. We have implemented title and author for our books, and we have also implemented a custom toString method. So this is really a lot, to be honest, but we will do more. Now, so far, we have been declaring all our methods and our properties as public. But to be very honest, this is not something you should be doing a lot. Let's learn about something called a constructor. As you can see, when you are trying to create a new user, you are saying user, then name of the user object equals new, and then you are writing the name of the class once again and then a set of parentheses, as if you are trying to call a method called user. Well, that's kind of true. Every single class that we have in Java has a special method called constructor. This method is responsible for initializing all the properties with their default values. So what we can do is we can customize this constructor method and make it do things. Let's start by writing a constructor for our user class, okay? We will say user and we will not write anything like public or maybe some sort of return type, nothing at all. We will just start by writing what the name of the class is. Then we will put a set of parentheses and a set of curly braces. So this is our constructor method. Now let's think about what we want from the user when they are creating a new user object, right? We want their name, so we will receive or ask for their name, and we will also ask for their birthday. Now this birthday can be taken as a local date, but we will take it as a string. I will tell you why. Birthday. Now inside this constructor method, we will say this dot name equals name, and this dot birthday equals local date dot parse birthday. So what we are doing essentially is we are asking the user for a name and we are storing that name in the name variable or name property within the user class. Then we are also asking for a birthday and we are storing that birthday in the birthday property. But since the birthday property is of type local date, we will have to parse the birthday from string format to local date format. Now let's go back to our hello world class and make the necessary changes here. We will say user equals to user and we will put the name inside this constructor call and we will put a comma here and we'll also put the birthday within the constructor call because now the user class is capable of accepting these two values. Let's run the code and see if everything works just as before or not. Seems like I have made a small typo here. The D should have been capital. And it works just like before. Now, since we can initialize the user with a name and a date of birth right at the creation process, we can actually make the name and birthday private, which means we can no longer do things like user.birthday or user.name. But we still need to know the user's name and user birthday, right? For that, we have something called getters. So we will create a new method somewhere in this user class, public get name, and the return type be string, and we will say return this dot name. And we will also say public string get birthday and we will say return this dot birthday dot to string. Now let's go back to the hello world class and make use of these two getters. We will come down to printf and we will say user dot get name and we will say user dot get birthday, and we'll get rid of the toString call since the birthday will come back as a string by default. Now let's run the code and see how it works. Okay, we also have to replace this name here. And as you can see, since we have made the name properties private, the hello world class actually fails to access the user's name, which is a good thing. I will explain why. Let's just make it working again. So yeah, it's back to normal now. Now since the name and birthday properties have become private, no one can change their values from outside the user class, which means these are now much more secure than they were before. Another thing that is, now we can pass the name of the user and the birthday as strings. The hello world class has no business in knowing what is the actual type of the birthday is. All the hello world class needs to know that if it passes a user name and a birthday in string format, a new user will be created. This is called abstraction. So what we are doing is we are hiding the complexities of the user class behind these beautiful looking getter methods, constructor methods. You can already see how cleaner the user object creation looks compared to the book object creations. Let's make the same changes to the book class as well. So we will go back to it and change the title and author to private. Then we will implement two getter methods. So public get title, return this dot title. The return type will be string, and then we will say public string get author, and we'll say return this dot author. Excellent. Let's also implement the constructor. So we will say book. We will take the title as a string, and then we will take the author name as a string. Then we will say this dot title equals title, and this dot author equals author. Nice. Let's update the creation process. So we will pass the title of the book and the name of the author with the new keyword and get rid of that. Excellent. The program already looks much cleaner. Now, another thing that I would like to change is I would like to make the books list private and implement a getter for that as well. So let's go back to the user class and let's say public, and this time we will be returning a string borrowed books, and we'll say return this dot books dot string. Excellent. Now the hello world class doesn't know about the complexities of the books list either. We'll just say borrowed books. Did I make it private yet? No, I didn't. So we will make it private. Okay, let's see if the program works just as before or not. Excellent, the program works just as before. Now, I hope you can already see the beauty of object-oriented programming and how cleaner the program actually looks in reality. We still have to learn a few more concepts around object-oriented programming, such as inheritance. Now, assume that our book borrowing system has multiple types of books. There can be the regular books, I mean the hardcover ones or the printed ones. Then there can be ebooks and there can be audiobooks. Now, although they have some similarities, they also have some differences, such as the ebooks and the regular books have page counts, while the audiobooks have runtimes. Also, the ebooks have formats such as PDF or EPUB or so on. So, trying to implement different kinds of books using the same class can be cumbersome. Now, you may think that you will make copies of the book class and add or remove the necessary properties methods to them. But that's not a very good idea. This is where inheritance comes in. So we can make a default book class with the most common properties and methods in it, and then we can make child book classes that will inherit all the properties and methods from the parent book class, and we can also add some new properties and methods to them. Let's see an example. First, we will add the page count property to the book. So we will say private int page count. And for that, we will have to pass the page count to the constructor here. So we'll set this dot page count equals page count. We'll go back to our hello world class and we will say, I don't remember the actual page count of the book, but let's put 270. Nice, everything should be normal. Let's run the code and make sure. That was a silly mistake. I didn't accept the parameter here. Let's run the program and make sure. Excellent. Now we will create a new audiobook class. Audiobook.java. Yes. And we will say public class audiobook extends book. Now, since we are declaring this audiobook class as an extension of the parent book class, it already has all these properties and methods we have described here. So what we need to add is a runtime. So we'll say private int runtime. So runtime means how long these audiobooks run. So the runtime will be in minutes. Then we will have to create a new constructor here. So we'll say audiobook, just like before, and we will accept the runtime. So we'll say int runtime. And then inside the pair of curly braces, we will say this dot runtime equals runtime. Now, here is a problem. I have already said that since this audiobook class is an extension of the book class, it also inherits all these private properties, which means we will still have to fill them up somehow. But the audiobook constructor doesn't accept any of these values. Okay, let's see what we can do to solve this. First, we'll copy all these parameters from the book constructor and add them to the audiobook constructor. One of the problems have been solved. We are now accepting all the necessary information for the parent book class. Now we will say super and we will pass title, author, and page count. Now, the super keyword here actually refers to the parent class of our current class. So, when we are calling the method super, we are actually calling the constructor of the parent book class. So, we have successfully filled up all the necessary properties of the parent class as well. Let's try out by creating a new audiobook. Let's go back to the Hello World class, and after book, we will say audiobook equals new audiobook, and we will say Dracula, and the author is Bram Stoker, and the page count. Actually, we do not have to pass the page count here. We can modify our constructor a little bit. We do not need to accept the page count here. Instead, we can pass 0 as the page count. Yeah, that would be better. And we can just accept the runtime. So, for example, maybe the Dracula book would run for 30,000 minutes. So, I put 30,000 there. Audiobook. See, I have made a mistake. Dracula. And I think we should start naming our books. So, Carmilla. Okay, so we have successfully created a new audiobook here. Just for the sake of our code's clarity, let's get rid of all the code that we do not need. So we will get rid of the user.borrow call. We have seen examples of that. We'll also get rid of the system.out.printf calls. We will get rid of the user as well, because for now we will be focusing strictly on books, audiobooks, and ebooks. So let's create a new system.out.printf method here. We will say println, Dracula.toString. Because remember that the audiobook class already inherits the toString method from the book class. Okay, let's print out something on the screen. So we'll say system.out.println and Dracula.toString. Let's run the code and see if it works or not. Yeah, it works just fine. Okay, now that we have an audiobook class, let's create a new class called ebook. Java. Okay, again, public class ebook extends book. And then within the set of curly braces, actually we can copy a bunch of code from here. Let's copy everything to the ebook class, and we will say private string format, and then we will accept everything, and we will also accept the page count this time, because ebooks have page count. Okay, so I'll put page count, and then we will also accept the format. So we'll say string format, this dot format equals format. Yeah, nice. Yeah, everything looks fine. Okay, we have to change this to ebook. Now let's go back to Hello World and try to create a new ebook. Okay, so ebook. So Jeeves, I will create a Jeeves book, new ebook, carry on Jeeves, written by PG Woodhouse. I hope I'm spelling his name correctly. Then the page count would be 280, I guess. And finally, the format will be PDF. Let's put a semicolon there and let's see if the book has been created properly or not. So jeeves.tostream. Okay, so Carry On Jeeps by PG Wodehouse. So we have successfully created different kinds of books based on a parent class. Now, this is what I had in store for this course in terms of object oriented programming. I have taught you what are classes, what are objects, what are properties and methods, constructor methods, and you have also learned about inheritance. Now, there are a lot of things that you will have to still learn, like method overloading and overriding, abstract method, and whatnot. But I would not like to overwhelm you with all these concepts in a single course. What I would suggest that try to understand everything that I have taught you in this course as thoroughly as you can, and then keep practicing. Make programs, make bigger programs, and try to understand whatever concept seems complex to you. And as you keep working with Java, as you keep making more and more fun projects, you will start to understand a lot of the complex concepts around object oriented programming and whatnot. So I hope you have learned something good from this course, and maybe someday I will see you in another course as well. So till then, stay safe and take care.